Alright, so we're doing some GCF LCM word problems today. I went ahead and wrote down these words because I didn't want to spend our time me writing these words down. So if you need to pause it and write these real quick, you can do that. These are super important words because a lot of people freak out when you talk about word problems or when you're solving word problems. But if you have this list of words right here, it will make your life a million times easier because literally every single problem is going to have one of these words in it. Maybe sometimes they might have words in it, even easier. You can identify what type of problem it's going to be. They're all going to be solved using birthday cake, but you just have to figure out which one of these words is in the problem, and then you'll know whether you're doing birthday cake for LCM. I really enjoy teaching this topic because a lot of kids get discouraged when you talk about word problems. But like I said, these word problems are so easy because they make it so clear for you to see which type of problem you're going to be solving for. So like I said, if you haven't written these down yet, pause me right here, write these words down, and then keep going afterwards. But I'm going to keep going with the problems so that you can see exactly what I'm talking about. So you don't have these problems because we're just using them for notes. It's not your actual assignment for the day. But this is what type of problem that you'll see in your homework tonight. So it says one trip around a running track is 440 yards. One jogger can complete one lap in 8 minutes. The other can complete it in 6 minutes. How many minutes will pass until the next time both joggers arrive at their starting point together if they start at the same time and maintain their jogging pace? A lot of words going on in that problem. Pretty much all they're saying is at some point, obviously when they start the race, they're running side by side. But you can clearly tell that one of them is faster than the other one. But what they're saying is if they keep running long enough, eventually they're going to be side by side again. So we're trying to figure out how many minutes are going to pass before they're side by side again. And so like I told you, use the words that I wrote down to figure out which word is in this problem. And it might take some searching, but eventually you'll get used to identifying those keywords. And you will see that the words next time right here. So I can see that next time is on my LCM list, so that tells me that I'm going to be finding the LCM of 6 and 8. 440 is definitely in that problem just to mess you. So don't fall for that trick. Nothing else goes with 440 yards, but yet you can see that this is 6 minutes and 8 minutes, so they kind of go together. 440 yards has no connection to anything. It is only there to mess you up. So, like I said, we can just ignore it. So in my notebook, I'm going to solve these. So this is an LCM question, so I'm doing upside down birthday cake. I've got 6 and 8. Those are my two numbers. What goes into 6 and 8? Well, that would be 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Put my 1. And now remember, it was the word next time. So that means I'm doing LCM. So I'm doing this side and this side. So now I'm just going to multiply. So I'm going to multiply 2 times 1 is 2. 3 times 4 is 12. So 12 times 2 gives me 24. So what that tells me, to go back to my question, it says how many minutes will pass until the next time both joggers arrive. Well, that would be 24 minutes. So after they've been running for 24 minutes, they're going to be side by side again. Okay? All right, let's look at the next one. Mr. Smith waters one of his plants every 10 days and another plant every 14 days. If he waters both plants today, when is the next time both plants will be watered on the same day? Okay, so once again, you're looking for those key words that help you figure out which type of problem this is going to be. And I immediately see that I've got every. And if you go look at your list, every is on my LCM list. I left it a blank right there because it's obviously not talking about the same thing every time. This time is every day. Sometimes it's every week. Sometimes it's every month. Sometimes every week. So it all depends on what it's talking about. But it's always going to be every. If you just every, it's not important. But when you see the two everys side by R to each other, that's talking about an LCM problem. So I'm finding the LCM of 10 and 14. Okay. So let me bring that over here. So we said it was 10 and 14. What goes into both of those? That will be 2 again. 10 divided by 2 is 5. 14 divided by 2 is 7. Only thing that goes into those two is 1. We said it was an LCM question. So I'm doing 5 times 7 is 35. 35 times 2 is 70. So once again, looking back at my problem, it asked me, when is the next time both plants will be watered on the same day? Well, that would be in 70 days, which seems crazy, but that's what it is, all right? And you need to pay attention to what you're talking about exactly. Like, what if I put 70 plants? Well, that's not what the question's asking me. The question's asking me about when is the next time. So the time is talking about days, so that's why I knew that it had to be days. All right, let's look at the next one. Seth has 15 cans of regular soda and 20 cans of diet soda. He wants to create some identical refreshment tables that will operate during the high school football game. He also doesn't want to have any sodas left over. What is the greatest number of refreshment tables that Seth can stock? All right, so once again, a whole lot of words going on there, but I immediately key in on this word right here. Okay? This one is super, because what does the G and GCF stand for? And hopefully you remember it's greatest. I will say they use one a lot for GCF problems. The greatest is definitely one they stick to. But you'll notice on your list that it's not just greatest, but all these other words, a lot of them mean the same thing as greatest. Biggest, largest, most, just huge. All of those things kind of mean the same thing, which is greatest. So that's how I know it's a GCF problem, because I see the word greatest. Now let's identify what numbers I'm using. That would be 15 and 20. So now let me set up my birthday cake. 15, 20. What goes into both of those? Well, 5 goes into both of those. 5, that's 3, and this is 4. That would be a 1. And we said this was a GCF problem. So therefore my GCF is equal to 5. So now let's go back to the problem to figure out what it's talking about. So it says, what's the greatest number of tables? So therefore it would be 5 tables. Now something else that they might ask you sometimes extra is they might ask for specifics. So what I mean by that is, if I have 5 tables, well, how many cans of regular soda are at each of those tables? Okay, so the question might go on to say, how many regular sodas are at each table? Well, then you got to think about it. If you have 5 tables, there's 15 cans of regular soda. Well, then that would be 3 sodas at each table. Same thing for the diet ones. If you've got 5 tables, 20 cans, that's 4 cans at each table. So sometimes you got to be careful about what specifically they're asking you for. But either way, I had to find that GCF to figure out how many tables there were going to be. But also I want to draw your attention to, remember I just told you that the two numbers were 3 and 4. Like, there would be 3 cans at each table. There would be 4 cans at each table. Well, if you look back at your birthday cake, those numbers are right there. So at the bottom of your birthday cake, that bottom layer, you take specifics of what you're looking for. You just need to pay attention so you don't get mixed up. So what I mean by that is 15 went with the regulars, 20 went with the diet, so that still applies down here with the 3 and the 4. Okay? All right, let's do another one. So it's a lot of words, okay, but don't panic. I think you've seen how easy these questions are, so it's not going to be it's just a lot of words taking up a lot of space, but it doesn't mean that it's a problem. So it's hard to bring snacks and juice for the soccer team. At the grocery store, some juice boxes and cookies that were on sale. The juice box come in packs of 6. The cookies come in packs of 8. If Greg wants an equal juice boxes and cookies, what is the minimum number of juice boxes he should buy? Okay, so this is talking about going to the store, juice boxes and for the soccer team, but he doesn't have like extra juice boxes, but sell cookies to get rid of both of them. So he's trying, how many do I need to buy so that it's even? So let's look at our keyword, and I see right here that it says minimum. And so therefore that minimum, well, minimum is the same thing as least, and I know that least is LCM, but also minimum is on this list. But once again, kind of like biggest, same thing as greatest. Minimum is the same thing as smallest or least, so that tells me that it's going to be an LCM question. Now let me identify numbers that I have. My number 6 and 8. So let's find the LCM of 6 and 8. So 2 goes into both. 6 divided by 2 is 3. 8 divided by 2 is 4. Remember, this is an LCM question, so I'm doing this and the bottom. Down here, 12. 12 times 2 is going to give me 24. Okay. So now here's what I meant when you had to be careful of what it's asking for. So it says, what is the minimum number of juice boxes he should buy? Only talking about juice boxes. But when I found the LCM, I was talking about juice boxes and cookies. What's 24 right here is that I need to buy 4 of each. I need to buy, so I'm going to have 24 cookies, and I'm going to have 4 juice boxes. Okay. Well, now you have to take it to another level. All right. If I have 24, if I want to have 24 juices, they come in packs of 8. How many packs do I need to buy in order to have that 24? So my LCM, I'm going to put L equals 24. Okay, but it says what's the minimum juice boxes he should buy? Well, he's going to buy 24 juice boxes. So the question's a little confusing to me. So I'm going to put both, because he needs to buy 24 juice boxes. But if it was more specific and it said how many does he need to buy, well then you would have to put to buy 3 packs. Because think about it, they come in packs of 8. He needs 24. So he would need 3 packs. So whether the question wants to know how many specific juice boxes he needs 24, because that was the else I got. But if he wants to know how many specific packs he needs, that would be 3. Okay, so that's just going to show different types of questions they could ask. All right, 2 more. Kevin is creating lollipop bouquets using 15 cherry lollipops and 18 orange lollipops. He wants each bouquet to be identical with no lollipops left over. What is the greatest number of lollipop bouquets Kevin can create? Again, immediately I see greatest. I know that greatest is on my GCF list, so I'm finding the GCFs of 18 and 15. So let me do my birthday cake. So 18, 15. What's the number that goes into both of those? The first thing I want to think of is 3. 18 divided by 3 is 6. 15 divided by 3 is 5. What goes into 6 and 5? That would be 1. And we said the word was greatest, so this is a GCF problem. So my GCF is 3. So now let's go back and look at the problem to make sure I'm answering it correctly. What is the greatest number of lollipops bouquets he can make? And that would be 3 bouquets. Okay? Once again, if it were to ask the next question, if there's 3 bouquets, how many orange lollipops are on it? Well, I've got 18 orange lollipops, 3 bouquets. That means that there would be 6 orange lollipops on each bouquet. And if I go back to my birthday cake, there's the 6 that I'm talking about. Okay? All right, 1 more. Pamela is serving plates of vegetables at a homeless shelter. She has 30 carrot sticks and 45 baby potatoes that she wants to divide evenly with no food left over. What is the greatest number of plates that Pamela can make? Once again, greatest. I told you that's a big one that they use a lot. So greatest, and I'm doing greatest for 30 and 45. Remember, greatest is on my GCF list. I'm finding the GCF of 30 and 45. What goes into both of those? First thing I think of is 5. 30 divided by 5 is 6. 45 divided by 5 is 9. What goes into both of those?